Welcome to Study Loop.
For our question, we have the length of a rectangular piece of sheet metal given as L, and it's equal to 12 millimeters, and the width is given as W, and it's 5.98 millimeters. So for part A, in multiplication or division, the number of significant figures in the result must be equal to that of the number which has the fewest significant figures. L has the fewest significant figures with 2, so in all of our answers, we're going to report to 2 significant figures. For part A, we're asked to find the area, where here, area is just going to be equal to length times width. So plugging in the values for length and the value for width, we find that the area is equal to, and again, reporting 2 significant figures, it's 72 millimeters. So we can box 72 millimeters in as our solution for part A. Part B wants to know the ratio, which I'm going to call R, of the width to the length. So the ratio of the width to the length is just going to be W over L. Again, 2 significant figures is all we can report to, and it's going to be approximately 0.50. We can box that in as our solution for B. Part C wants us to find the parameter of the rectangle. Parameter of the rectangle value, we're going to call this C, is equal to 2 times W plus L. Or W plus L plus L, but just 2 times W plus L will also work. And this comes out to equal 36 millimeters. We can box that in as our solution for C. Part D would like us, let's see. Part D says, what is the difference between the length and the width? So that's pretty simple. We just do L minus W for that difference. L minus W comes out to equal 6 millimeters. If you do 12 minus 5.98, it comes out to equal 6.02, but again, we can only report to 2 significant figures, so it's approximately 6 millimeters. Box that in as our solution for D. And then lastly, part E wants to know the ratio of the length to width. So part B was the ratio of width to length, but part E is length divided by width. So plugging in our value for L and W. Now let's make that width look a little nicer there. There we go. We find that this is equal to about 2.0. We can box that in as our solution for E in the final